Hello, good morning. In today's developer cloud coaching session, we'll be covering the NAT on the OCI Network Firewall feature. We'll start by giving a brief overview, then we'll cover its main use cases, and finally we'll conclude with a demo. My name is Ricardo Anda, and I am a cloud networking BlackBelt coder in EMEA, and today I will be co-presenting with my colleague Gerald. Feel free to join our EMEA Developer Cloud Coaching OCI public Slack space. A safe harbor statement. And now let's begin. The OCI Network Firewall is a cloud-native managed firewall service that is built using Palo Alto Networks technology. Within the OCI Network Firewall, customers can define security rules, decryption rules, tunnel inspection rules for bit-up mirror traffic, and NAT rules, which will be the main focus of today's session. Some of the benefits that customers get by using the OCI Network Firewall. First, it is a service, so this means that customers do not need to manage any of the underlying infrastructure. The service will be resilient, will be auto-scalable, and will be always up to date. The OCI Network Firewall is deeply integrated with OCI, logging, and metric. It provides a layered defense, advanced threat protection, and it helps customers meeting their compliance goals. The OCI Network Firewall can be used for inter-VCN traffic inspections, so this means for inspecting traffic from VCN A to VCN B. It also supports intra-VCN traffic inspection, so this means in a VCN with multiple subnets, it is possible with the OCI Network Firewall to inspect the traffic of these different subnets. And finally, the OCI Network Firewall is also capable of inspecting traffic that is coming or egressing via the internet or the NAT gateway. So what exactly is the NAT on the OCI Network Firewall? It is a capability that permits to define NAT rules to enable source NAT, allowing many-to-one translation. So what are some of the benefits of doing this? First, it helps optimizing the IP address usage. Then it helps facilitates the implementation of shared services model. It helps addressing the challenges with overlapping IPs, and it unlocks multi-tenant, multi-customer, multi-operational entity connectivity architectures. So how it works? First, within the firewall policy, another set of NAT rules must be configured. These rules can match specific source and destination addresses as well as services. Then, the outgoing traffic gets its source IP replaced with an allocated address from the firewall subnet. So, some important considerations. The first one is that the firewall can perform only private NAT operations. Remember that for public NATing in OCI, we offer the OCI NAT gateway. The second one, which is really important, is that the NAT IPs are assigned from the firewall subnet exclusively. So remember this when architecting the OCI Network Firewall. And then finally, the NAT capability requires a minimum of 4 to 5 IPs. So we usually recommend reserving additional IPs for the future growth of this pool. Okay, so what are some of the use cases that we see? We'll start by a use case where a customer is fully in OCI. This customer has multiple operational entities, and each of them need to connect to a common service in a shared VCN. In this example, the app subnet has the same IP address in all of the operational entities. Therefore, it will not be possible to reach the shared service VCN without creating a conflict. For solving this limitation, a NAT policy will be configured in each of the OCI network firewalls with the objective of NATing the source IP of the app subnet. Remember, important, that the NAT pool will be the firewall subnet. Therefore, the firewall subnet of all the firewalls of all the different operational entities must be different. So, after this rule is applied, now traffic will be source NATed in the OCI network firewall, and it will be possible to connect with the shared services without conflicts. This means that now all the traffic coming from all the operational entities will have a different source IP, and this source IP will come from the firewall subnet. Other scenario that is quite common is for enterprises that has a shared service, but instead of having this shared service in OCI, they have it at on-prem. From a design point of view and configuration point of view, is pretty much the same. So assuming that all the apps subnets is the same, for connecting to this shared service, there will be needed to do a source NAT. The OCI Network Firewall policy will be capable of doing this, and therefore it will be possible of connecting to this shared service and at on-prem via a fast connect or a site-to-site VPN without creating a conflict. Now my colleague Gerald is going to go through a demo where he will explain in detail how to actually configure and how to actually use the NAT on the OCI Network Firewall feature. So thank you.
Thank you, Ricardo, for this introduction on the OCI Firewall NAT feature. My name is Gerald Buchholz, and I'm a black belt for OCI networking here at Oracle. Before I'm going to jump into the actual demo, let me show you what we've deployed here. We've deployed 2 virtual cloud networks in the region of Milan. Both contains DRGs, and they're connected through an RPC. The network on the left side includes the subnet for the OCI firewall and also a subnet for clients that will be calling the web server on the right side. The right side web server will reply with the actual IP address from the calling host. In the portal, you see that we have 2 virtual cloud networks here. One is the hub virtual cloud network and one is the shared services cloud network. Let me start with the shared services cloud network. We have one routing rule here. Actually, we're using the default route table where I've added one rule that will send all traffic from the customer network back to the DRG for this shared services VCN. And then we have the hub virtual cloud network. The routing is a little bit more complex here because we need to have one routing table that actually forwards the traffic to the firewall, which we're doing with the public subnet to firewall route table, which contains a route rule that whenever we're calling IP addresses or when we have traffic towards the IP range 192.168.0.0/16, it will hit the firewall as the next hop. On the other side, we have the DRG traffic to the firewall because when the traffic coming in from the DRG, it also needs to be steered towards the firewall because the firewall is stateful and needs to have the return traffic as well. So we see that actually traffic towards the 10.0.10.0/24 networks, where our clients are located, will have 10.0.20.50, which is the IP address of the OCI firewall as next hop. Let's take a look at the OCI firewall and how it's configured. So our firewall is the NAT demo firewall 2, and we have NAT enabled, and it has an associated firewall policy named NAT test. If you look in the details of the firewall, you'll see that the NAT IP addresses that are associated with a firewall. So whenever traffic is source netted, it will be coming from one of these IP addresses. Let's take a look at the network firewall policy. As we've seen, it is the NAT test firewall policy that we're using here. And we have a security rule that basically allows all traffic. And then this is important for us here, a NAT rule that actually will translate the traffic from one client machine with source NAT from the pool. So let's take a look at the NAT rule that we have here. Take a look at the NAT rule details, and it will have a matching conditions of only client 1, which is an address list that I'm going to show you now. And we see this is the address list only client 1, where when we look at the details, it will only translate traffic coming from 10.0.10.14. As you remember, it was client 1 that was actually used here. So now let us go to the terminal, and I'll show you how it looks in the portal, how it looks in the CLI when we're going to access the web server. What I've prepared are 3 machines, a web server, and to clients. As you remember, the clients are coming from the 10.0.10 network. And to give you an overview of how these looks like, I've just opened it so that you can see here the client source IP addresses. That's the 10.0.10.14. This is the machine where the traffic will be translated when I'm going to call the web server on the right side here. And then I have the second machine where the traffic will not be translated. So I'm going to start a TCP dump on the web server so that you see the incoming packets. Let me first call from the client where the traffic will be translated. As you can see, the client's IP address is 10.0.10.14. If I'm going now calling the network address on the other side, you see the request is coming from the 10.0.20.10, hitting the web server here. So you see that the traffic is translated, and also the web server throws me back my translated IP address. If I now look at the other client that doesn't have the NAT feature enabled, you see that actually my origin IP is coming back. So my web server reports that my IP address is the same that I sent, so it's not source NATed. And we're also seeing the same here on the web server because the request is coming from 10.0.10.232. So we see how the NAT feature works and how it can be used to actually overcome limitations that are introduced due to overlapping IP addresses. I hope you found this demo useful. Thanks for watching.